Steps to find the vertical asymptote. We need to figure out, is it already factored? I'm going to be using the Xbox method. And then, can we cancel anything? Well, that's going to be your removable whole. And then we're going to set our denominator not equal to 0. So the directions are in our 3 examples. Find the vertical asymptote or wholes for each of the rational functions. Okay? Class, yes or no? Is it factored? I don't have to factor anything. Can I cancel anything? No. And then now we're going to set the denominator. And the reason why I said not equal to 0, do you guys remember finding the domain algebraic rational function? We had set it not equal to 0. You guys remember that? In some ways, it's supposed to be equal to 0, and I'll show you why. This one's super easy. The answer is what? X can't be equal to 0. And I just want to do a really quick visual. Just put in your graphing calculator. 5 divided by x. And basically you can see the vertical asymptote on the x. If you put your finger at x equals 0 and then draw a vertical line, there's your vertical asymptote. Does that make sense? So the vertical asymptote is essentially at x equals 0. We just don't want x to be 0 because if you put in 0 here, 5 divided by 0 is undefined. Okay? Alright, let's do g of x now. Let's use a different color pen. Yes or no? Is this factored? Yes. Is this factored? No. So I'm going to write this one as x minus 1 over x squared plus 0x minus 1. Why did I write that 0? Because when you factor this, a times c, negative 1. B value, 0. Two numbers that multiply to be negative 1, but add to be 0. Negative 1 and positive 1. So that means I'll have x minus 1 over x plus 1 and x minus 1. Raise your hand if you factor yours just like that. Good. This is a difference of squares. If you don't know what that means, not really important. What is important is you know that there's a 0x and that can help you factor it. It's essentially a trinomial and you just have to put a 0 there. Okay. Well, is it factored now? Can we cancel anything? Okay, so watch this. The canceling is the x minus 1s, yes? So we can say a whole is at x minus 1 equals 0. And if you solve for x here, you get x is equal to 1. There is going to be a whole, a donut hole, at x equals 1. Now, we're going to set the denominator not equal to 0 to figure out where the vertical asymptotes are. And so you get x cannot be what two numbers? Negative 1. And over here, if you add 1 to both sides, you get x is not equal to 1. Raise your hand if you got that. Let's punch into our calculator to give ourselves a visual. Right? We're always trying to connect Vang, right? How everything's kind of connected together. Parentheses, x, subtract away 1 divided by x squared minus 1. And then I expect to have a vertical asymptote at negative 1. At positive 1, I expected the graph not to go through my vertical asymptote, but we have a hole at x equals 1. So on your graphs, then you should have what there? A hole, an open circle. Okay, let's do the last one. Class, is this factored? If you factor it, let's practice our factoring. Class, a times c 6. B value? Negative 5. My two numbers that multiply to be 6 but add to be negative 5. Negative 3 and negative 2. Order does not matter. So I have x minus 3, x minus 2. Raise your hand if you got that. Let's do the other one. Ooh, it's really hot. A times C, 12. My B value, negative 7. Two numbers that multiply to be 12 but add to be negative 7. Look what I'm doing. I'm not writing the negative 4 first. Why did I do that? Yeah, I want to see the canceling. So if I do the canceling here, this is my whole. I have a whole at x minus 3 equals 0. And then if you solve that, x is equal to what? 3. So I expect a donut hole at x equals 3. Set each of those equal to 0. Not equal to 0. Remember, that just means what numbers you cannot put in for x. But we do have a vertical asymptote there. You have x is not equal to what? If you add 3 to both sides, you'll get x is not equal to 3 and 4. Okay, see what that looks like? Okay, everyone say tainted. Someone in your house just went to the bathroom. Didn't wash their hands. And just prepared you lunch. Is that a good thing? Could you imagine that your answer is tainted? What am I saying? Wrong. It's possible that you factored incorrectly and you have a bunch of wrong stuff over here, right? So if you want an accurate picture, go back to the original problem. Let's graph it. X squared minus 5x plus 6 divided by x squared minus 7x plus 12. Zoom 6. I expect to be a vertical asymptote at 4, and then there's a hole when it touches my graph at 3. Does it make sense? So right now we're kind of doing everything algebraically, and we're just kind of reinforcing it graphically. And those are 3 examples of finding the vertical asymptote.